So in this video, I'll be going over problem 16 from the practice exam. So in it, I actually made a mistake in the solutions. Those have been updated now. What is available online is the correct solution, but one from yesterday, Saturday, had the incorrect solution. The reason why that is because I got a little sloppy when combining the equations together. So we've got this boy and the girl running. The one key thing is that the boy is starting ahead of the girl. So the boy is going to have an initial position, and that is given by x naught b is equal to v naught b times t, where that time is equal to 0.4 seconds. Because we also have another time, the time that we're trying to solve for, when does the girl catch the boy? So where I got sloppy was I did not use t to find the initial position, the t equals 0.4 seconds, but instead I kept it as the time to catch. So I dropped my label of t catch, where this is t start. We could label that. So that should be labeled t start to really be explicit about what kind of t we're talking about. So this is a good highlight of how, if you're not careful, if you try to do steps in your head, this is an easy way to make a mistake. So the key is we're trying to find the time that it takes for the girl to reach the boy. So the key to that, again, is the final position of the boy and the final position of the girl will be equal. If the girl catches the boy, they're going to be equal. So we know that the girl starts from a position of 0 because that's what we're calling the 0 position. So that means the boy is going to have some sort of initial position. So we need to figure out what this x naught b is. He has no acceleration, so that's 0, and we're left with v naught b t, which is what we had down here. And again, writing it out, I have the initial position of the boy is equal to v naught bt. What I did, which was sloppy, was that I ended up combining those two, where this should be time at the start, and this should be t catch. So be very careful when you're labeling, and this is a point where you could make a mistake, because this is incorrect. This is not right. So let's go ahead and let's take a look at how we should have solved it. So again, everything was fine with what was on there. It was just very sloppy notation leading you to the incorrect answer. So you start by setting their final positions equal to each other, and then you need to solve for each of those final positions. So the boy, the initial position for the boy is equal to his constant velocity times the time that it takes till the girl starts running after him. And so that was given in the problem as 0.4 seconds. So he's starting 1.2 meters ahead when the girl begins to run. And so this was the point that I missed in the original solution. I got sloppy and did not label those correctly. Then we know the speed that the boy is traveling at, and then again we're leaving time as is because that's what we're looking to solve. For the girl, she starts at an initial position of 0. The initial velocity, she's starting from rest, so we're just left with the acceleration term for the girl. getting everything to one side, then you can solve for t using the quadratic equation, which is what we are doing up here. And you find that time that it takes for the girl to catch the boy is 4.3 seconds. Then once you have that, you can just substitute that time back into your position as a function of time equation to solve for the position that the girl catches the boy. And you find an answer of 14.3 meters. So the whole process, the approach to the problem stayed the same. I made a mistake right here in terms of calculating the initial position for the boy. I got sloppy and used the same time for each, so those terms would have combined. But in actuality, that was incorrect, and I should have substituted in the time that it takes for the girl to start running after the boy, which is 0.4 seconds. So that was the key right here, this term. So where I had a 2, it should have been 1.2 plus the initial velocity times time for the boy. So if you have any questions about this, please just reach out. I can explain it further, but this was where the issue came about, where I used this expression for the initial velocity of the boy just to combine the first and second term of that position as a function of time equation, when I should not have done that, because those times are different. One's the time that it takes for the girl to start running, and the other is the time that it takes for her to catch the boy, which is what we're interested in.